Hello, Alizizam, and it is still me, Tural, and today's topic is about dependency injection in C#. At the end of this tutorial, you will understand what is dependency injection, what is the real value behind dependency injection, why you should use dependency injection, and of course, how you should use dependency injection in your .NET Core projects. Truth be told, this topic is a huge topic. It is, of course, possible to record one big video related to dependency injection, but I know that you will not watch it. So my plan is to have multiple tutorials related to dependency injection, which this one is going to be the first tutorial, and it is absolutely for beginners. There is no prerequisites to use dependency injection or to know any related design principles, patterns. I will describe everything from scratch, and at the end, you will feel comfortable to use dependency injection in your projects. So enough talk, let's switch to practice. In this tutorial, I will follow a little bit different approach, which first I will show you how dependency injection is working, why you should use dependency injection, and why you need to use dependency injection. And then we'll switch to theoretical side. As you know, I'm also a big theory lover, so I always follow theory first, but this is a little bit different topic. I think first it makes sense to fill dependency injection and then talk about theoretical side. In my Visual Studio, I have blank solution called the CodeByte solution, which I'm going to add new project, and it is going to be ASP.NET Core Web API. Why I'm not using Windows Forms, WPF, or Razor Pages, and so of course I can use them. But for me, it is really easy to explain things from the ASP.NET Core Web API perspective, because developing web APIs are popular nowadays, and also for ASP.NET Core Web API, we have built-in dependency injection that will help us to not to write things from scratch, but easily inject our dependencies. Okay, let's select our ASP.NET Core Web API. Let's create our project. It is going to be our di.api. Okay. And I'm not going to change anything from here, just use classical controller mechanism. What we're going to develop, this is a really simple application. I'm not going to use layered architecture. I'm not planning to make things really complex to show that I know everything. I'm just going to explain dependency injection. For that reason, I will have only one simple project, and it is our API. All the layers I will add as folders, okay? This is our project. What we are going to implement will have Web API. In our Web API, we'll have dependency from AccountService. For AccountService, we'll use account repository. As you know, they are just real exact implementations. We are not going to use interfaces, abstract classes. We'll have direct implemented service called AccountService. It has direct dependency from account repository, CardService, and card repository. Our Web API will use AccountService, and our AccountService will use CardService. I'm just going to show you what is the problem with using this approach. Of course, sometimes it is better to not to use dependency injection, because dependency injection is also can make your life hard. But in some cases, it is better to rely on dependency injection, and let's fill it together. Okay. Great, I'm going to add new folder. This is our services folder. This is our services layer, and we'll have another layer called repositories. I'm going to implement the implementation and contract stuff inside these folders. And of course, we need some sort of models here, okay? Models. I'm not calling it domain model because I will not write domain model. I will just provide the dynamic model that will help us to work with database. Okay. Great. And let's remove our weather forecast here first. And let's rename our controller to first AccountController. And for AccountController, I don't need this information. And of course, let's completely remove all this stuff here. Let's remove this name, and we'll just simply may return account information, and that's all. This is our simple template. I'm going to have our models folder account. This is simple account, which is going to be our record, and it has just simple account ID, string account name, and of course, GUID our card ID. That's simply okay, I guess. Cool. And now let's go to our services, right click. We talked that we will directly implement our account service. For that reason, I'm going to have account service. And in my account service, I will have a simple method called bind. The purpose here is I want to bind my account to my given card. So I have account information, I have card information. I want to bind this card to my provided account, and GUID account ID and GUID card ID are going to be our arguments in this case. Great. What we need to do first, of course, we need to check if we have this account information. This is a classical approach. I'm not going to dive into details. So you have some sort of a repository here. Let's implement it, add new class. So you're always doing something like this. Account repository. Okay, this is your repository. You really love to create leak abstractions. So we have account repository here and public account information, get account by ID. And of course, for the repositories, we always have asynchronous operations, task, account, and GUID account ID. We'll just check our account. I'm not going to integrate entity framework. For that reason, I will have simply in memory data structure and private list account. And this is my accounts. Okay. And from the constructor, I'm going to instantiate some account information. New account. First, let's randomly generate it. And let me just copy this stuff because I will use it. And account 1 is going to my account name. And this one also is our card ID. And next one is our next account, which I'm going to use already generated GUID value to search things really easily. Let's just copy. So you see, we have a lot of online websites that help us to generate GUID. So I'm just able to copy one from here. Let me just copy it from here. This is GUID dot not new ID but parse, and the same stuff is applicable here also. Let's just copy this stuff and let's paste it here, and it will start with 5. Cool. And now we are able to search for some value. Return accounts dot let's use, I guess, find right now. Find, and let's provide our account ID to account ID. You can use another methods here. It is completely okay for us to use it because right now it doesn't matter for us. The optimization stuff and etc. from result. And that should be okay for our account repository. And for the account service, I'm going to have our repository. Private account repository. This is my account repository. Okay. And I'm instantiating the exact instance of account repository. And for the account repository, I'm going to check if given account exists or not. And this is going to be task async operation. And here we have a wait var account information. That's okay. Account. Okay. If our account is null, then we'll return some information. For that reason, let's go to tools, new package manager console. I really love C# functional extensions. Install package C# functional extensions. Let's install this one. So let's see. Using C# functional extensions, I will return some sort of result here. So the task result account and string error. Okay, if account is null, then return result dot failure, and this is my account string no valid account ID provided. Great. And else we'll check our card ID. We'll use approximately same operation here. Okay. So I'm going to have CardService first, because in my AccountService layer, I will interact with not card repository, but with CardService, because for CardService, we will have additional business logic stuff. So let's right click, add class CardService. Okay. And for the given CardService, I will absolutely use the same stuff like this. Let me just copy. Oops. Let's just do it like this. Private card repository, because we need to check if we have a card, and card repository, new card repository. Let's go to our repositories, right click, class, and this is our card repository. Your lovely repositories. And let's just copy this stuff from here, paste it here, card, and let's create a simple card here, right click, add class card. This is going to be our record, and greet card ID, string card name. That's enough. Okay. And this is our card. This is also a card. New card with card 1, and of course card 2. Great. This is my cards, and I will return some card information. Get card by ID, card ID, and from the cards, we'll search for ID, card ID. Great. Let's go to our CardService. Okay, for the CardService, we have card repository, we have instantiated this one, and the same approach will follow here. And let me just from the service return public async task result. This is our result card string. Okay, let's add using get card by ID asynchronously, and we'll just delegate this responsibility to our card. Okay, get by ID asynchronously. Let's provide this card ID and await var card. If card is null, then return result dot failure card string. Okay, card string, not a valid card ID. Otherwise, return result dot success card information. Great. Now we have CardService. we are able to use our card service here, private card service. This is our card service, and let's instantiate it, and let's just go and use it. If our account exists, we need to check our card service, get by ID. Let's provide our card ID, and this is our awaitable operation, var card. And again, if card is null, then we will return response that something is wrong. Let's wait for it. This is result, so we need to check something like this: is failure. If something is wrong, then return result dot failure, and let's map it to our account string, and let's just provide the error message here. Error, that's all. Otherwise, let's say we'll bind somehow. What I'm going to do, I will have another method here for card service. I will add it to my repository. You can use a unit of work, etc. But for simplicity, I will just return that, return result dot success account string, and let's return our new account with given card. Okay, let's cut, paste it here, our account dot card ID. Okay, and for the given card ID, I will provide the responsibility to get this information. So I'm going to my account, and let's change syntax a little bit. And here we'll have public account with card ID, and return this with card ID equal to card ID. Great. And account with card ID, I guess, go to definition, and of course with card ID will be here, card ID, and let's provide our cards ID. Here is our card. So the result value dot ID, or we can use our card ID. That's also completely okay. Var new account. Let's get our new account and use our new account. This is our success case. So what we are going to do here, we are going to use our repository, direct repositories. You see, we have CardService here. We are directly using CardService. We are not using interfaces, etc. And this is going to be a little bit problematic for us, of course. And here we have the CardService, which is going to use our card repository directly. Now let's go to our controller here, and let's instantiate our private account service. This is our account service. Oops. This is our account service. And for the account service, let's instantiate this account service, and let's use it. Implement our binding process. For that reason, I will use HTTP post here, public task action result. Let's call it bind, simply bind. I will use GUID account ID and GUID our card ID. Okay, and let's call our awaitable, not add account service dot bind account card, and let's check var bind response. Okay, because we are returning result value here. For that reason, I will check if bind response is succeed. It means everything is okay. Then return okay with bind response dot value. Otherwise, it means something is wrong. Let's return, I don't know, not found, maybe not found, I guess. So let's see the loading version. I guess that should be okay. Let's just, I'm not going to provide the error message or etc. For the simplicity, that should be okay. And from the account service, I will use to return all data, public, list, account, get all, and I will just use account service get all. And of course, async and awaitable return. Okay. Great. I guess for the return okay, we will just simply use task I action result. Great. Let's just implement this method. Generate this method. Go to definition. Public task account, and let's return account repository dot. For the account repository, we should have get all type of things. Go to definition and public list account or enumerable account, it doesn't matter. Get accounts asynchronously. Return task that from result accounts dot, I think just accounts. Okay, so let's see, list accounts. Okay, task from result, task list. Great. And let's go to our account, get all accounts asynchronously and awaitable. Yes, we just need to make it list account. Get all asynchronously, and let's go and check if everything is working. Debug. Start without debugging, and let's see. We should have two endpoints, one for get and the second one for post. Great, now we have get. Let's go for it. Let's execute. And here we are. We have all this account information. To make the card list, not to refresh every request, we need to provide a static here. Let's go to our account also. Let's provide our static data and let's debug our application again. And here we are. Let's go to our get. Let's execute. So you see this is 8.1 but 9.4.9. Let's execute. The 4.9 states, but this will be different value because we have GUID.new ID here. So what I'm going to do, I'm just going to copy this information from here. Okay, and let's go to our account post. Let's provide our account, and I'm going to use the exact card ID. Right now, we don't have any special business requirements to not to have the same card with same account ID. So it is, of course, better to separate them. But anyway, let's check. And here we are. Everything is working. And let's execute. Now we have two values again because we haven't added to our repository, but that's completely okay. We are getting the success information. And that's all how we are simply implementing all this stuff. Of course, this is not a bit correct application to use. The purpose here is to show that we have multiple dependencies in our classes. For example, let's go for our account service. In our account service, we have dependency from account repository and card repository. And when you go to card repository, it has dependency from when you go to card service, you have dependency from card repository. Of course, that's completely okay. But what if I want to change my repository? So what is the problem? The problem here is I may have multiple implementation of my repository. I may have especially multiple implementation of my card service. But right now, my application directly depends from account repository, and it is internally implemented. This card service also, the account repository also. This is a big problem for us, because if you want to test your class, it will be really problematic, because in your application, if you want to stop it, to mockify it, you will just directly instantiate the real data, and it will be a huge problem for us. So what should we do here? Of course, it is better to provide it from the arguments, but if you provide it from the arguments, you have again direct dependency from the implementation. Let's say I'm providing this information here like this, but still I have direct dependency. Okay, so I'm providing this account information here, so let's provide it. I'm not going to instantiate any stuff here. Okay, this is my account repository, and for the card service, let's for the card service use our card service. Now it is a little bit okay, because it is possible for you to make this repo or these services, some functionalities virtual, to override it in your testing process, but still you have direct dependency from account repository and card repository. Let me just remove this one from here. And let's see, in this case, as you might guess, when you are constructing some class, you may have multiple dependencies, especially in our account service. What I want to do, I want to instantiate my account service, but my account service will require account repository. Let's instantiate this account repository here. Account repository. Account repository. Okay. And the second dependency is card service. Let's check this card service. But this card service also may have some dependency, which we are going to inject right now. This is our dependency here. Now I'm not going to construct it internally, but provide it from my constructor. Okay, the card repository, of course. Now here you see I have another dependency. So this dependency also may have another dependency, and this will be a big problem for you to construct your object. You see, now it is a bit complex. My account service requires a account repository, and on the other hand, it requires card service, which card service requires card repository. So you see, you have all the knowledge here directly in your controller, and every time when you use account service or some sort of complex service like account service, you will provide all the implementation manually in your code by your own. This is a big problem. And also, as I mentioned, another big problem is the main problem here is we have direct dependency from the implementations. For example, account service uses card service. What if I have a strategy-based card service? I mean, for example, right now I'm using this card service, but I will need another completely different implementation of card service. But my account service directly requires card service. So we need to somehow abstract out from this card service here. So it means you should provide abstract class or interface here to isolate your application from direct dependencies. This is the real purpose behind dependency injection. Okay, now let's talk about dependency injection. Dependency injection is an implementation form of dependency inversion principle, which we are going to talk about in our next tutorials. This is also a big topic. This is one of the principles of solid. The last D is dependency inversion. Dependency inversion means that your high-level modules shouldn't depend from your low-level modules. Both should depend from abstraction. In my case, I have account service here, and this account service has dependencies from account repository and card repository. Okay, and in this case, this is high level module, this is low level module, and I have direct dependency from account repository. Low level module depends from high level module depends from low level module, but it is better to have a communication like both should depend from abstraction. And it means in our controller, we need to do some additional refactoring. And how we can implement it, let's switch to our applications diagram here. We have Web API. Now, our Web API doesn't depend from account service. It simply depends from AccountService, okay? This is a special interface that will help us to inject, to use any implementation of this interface. It means I can in runtime to change my account service to another account service or any other account service that implements AccountService. So instead of having direct dependency from this implementation, I have dependency from high level stuff, and using this high level interface, I am able to inject the implementation, the exact implementation I want to have for my application. The same is applicable for account service also. In my account service, I don't have dependency. In our case, we have something like this. Yeah. So this is our just simple card service. And in this case, we have direct dependency from card service. Our account service uses card service. But when your account service depends from AccountService, it means you are able to provide any implementation of this interface. It might be the card service, Visa card service, Tempo card service, etc. So it provides us to have reusability, maintainability, extensibility, testability, because in our case, when we want to isolate our account service and to test it, it will not be possible, because in our account service, we have direct dependency from repository. It is not possible to unit test it if you are not configuring it to provide some virtual methods, etc. And this is a big problem for us. It is better to have dependency from the interface and to easily mockify it, stubify it. Okay, so you see, dependency injection is really helpful mechanism for us to inject the exact dependencies to help our layer to be work in isolated manner, to be tested in isolated manner. For example, right now our Web API, for example, our account controller knows about account service, and this account service brings another dependencies like repository, card service, card repository. So you see, we have all the detailed mechanisms here. So this is a big problem for us. We need to isolate our account controller to use to not depend from account service implementation, but depend from the exact interface of it. So let's refactor it. Right click, quick actions, and let's just simply, I guess, here we need to go to our account service and right click, quick actions, and here extract interfaces, and let's extract our account service interface. So you see we have bind, get all, that's great. And now our account service implements account service. I just want to go to my controller and provide that I'm using account service, and I will provide this account service from constructor to isolate my application to this implementation details. Okay, account service. Great. Now we have dependency from not to exact implementation, but from account service. So you see, we don't have any implementation details like the account service that uses the repository stuff, that uses card service. We have completely isolated our application from these dependencies. And now let's go to our card service. Of course, our account service, of course, requires our account repository, CardService. So we need to isolate them also. Let's go to our account repository, right click, quick actions, extract. I'm creating the same stuff for this account repository. Let's follow the same mechanism here for card. Let's create our interface and let's go to our CardService and let's create our interface. Yes, so you see per class right now we have an interface, and it means right now my application will not depend from any implementation low-level details. Let's go for CardService and let's isolate our mechanism here. Okay, this is going to be iCard repository, and from the constructor, I will provide iCard repository. The same is applicable for AccountService. I will provide AccountService, iCard service, and from the interface, iAccount and iCardService. It is possible to implement dependency injection using different mechanisms: constructor injection, method injection, property injection. We'll talk about it. This is also another big interesting topic, but for now the popular one is injecting stuff from the constructor. So from the constructor we are providing these interfaces, and you may think that okay, we have implemented this stuff, it seems really cool, but how will provide these interface to CardService, because we are not using the CardService itself, but we're using this interface. So it is also really easy. Let's go for our account controller. So you see in our account controller, we have AccountService. This should implement, we will use AccountService implementation, which is going to use account repository and CardService. And let's configure all these dependencies together. To configure dependency injection, we have program CS here. Okay. In our program CS, we have the building process. We have builder here, and we have services. So you see, add services to the container. It means I will provide builder services add transient. We'll talk about add transient right now. This add transient will help us for every request to create a new instance. This is similar like to add scoped, but in add scoped in one request life cycle for the different classes. If you have the same implementation, if you have same interface, system will provide the same instance, but for add transient, it will provide every time a new instance of your object. This is not a big problem for us. We are not concentrating to add transient, add scoped, add singleton. We have 3 ways of injecting these dependencies. Right now, let's just try to focus to inject it. About lifetime, we'll have another sessions. Okay, I'm just going to use AccountService. So it means when you see AccountService, try to create an instance of AccountService. Okay, and when we run our application, in our application, you see we have AccountService interface, and when you run it, we have built-in dependency injection container, and it will monitor our controllers, whole classes, and it will check, okay, we have injection here. We need to provide AccountService. Okay, it will check this list, and we'll see that we have AccountService. It means when you see AccountService interface, when someone requires AccountService, provide exact implementation of AccountService. And let's just copy. For our AccountService, we need to provide account repository. When you say account repository, provide account repository. And when you see CardService, provide CardService class. And when you see card repository, provide card repository here. Okay, so it means when we are calling our account controller, it will check if we have dependency or not, and if we have exact dependency configuration in our container or not. We are configuring our dependency injection using builder services add transient, add scoped, and add singleton. You see, we have add scoped here and add singleton here. Just now focus to implement to make your application to run successfully rather than to think about transient, scoped, and singleton. Let's run our application. When something is wrong, system will notify that you have this dependency, but you don't have anything configured related to this dependency. So let's see if we are able to run our controller successfully. It means all the cases related to dependency is working. So let me just refresh. Let's go execute, and here we are. Everything is working. We are calling our account service, and for the account service, we are getting the exact instance of account service, and this account service requires CardService and account repository, and our dependency injection container will provide instantiate our objects in a proper manner. I hope I could explain dependency injection as simple as possible. For today, that's all from my side. I will have separate topics related to dependency injection like dependency inversion principle, the lifetimes like singleton, scoped, transient. But for now, this is the first tutorial that will help you to understand the basics of dependency injection. If you like my videos, please don't forget to subscribe, hit like button, share, and I will see you in the next tutorials. Bye.